Hi, everyone. So I know I'm the last person standing between you and what's next, so I'll try to make this go as quickly as possible. This talk is about making Beam simpler and more powerful, or how I learned to stop worrying and write simple, easy-to-read Beam pipelines. So when we started Apache Beam, actually even earlier, when we started the original Dataflow SDK that Apache Beam was based off of, one of the statements was our goal was to make simple things easy and hard things possible. It's a very trite-sounding expression, but it's actually extremely difficult to do both. You see many similar APIs either veer to one side and just focus on what's the easiest to use API we can do. Okay, we can't solve this problem, but we'll add more functionality later. And then it turns out that you run into roadblocks. You run into parts where you've made things very simple and you can't make it more powerful. And an example is APIs that were based off of processing time timestamps and found it very difficult to just simply add event time to the API later for streaming. So, let's start with Beam. Beam, we all know Beam is a very simple API to use, at least sometimes, if you're doing very basic things. So, if for example here, let's say I'm reading from PubSub or from Kafka, and I want to count how many events there are per user. Well, I can just read from PubSub, map it to a key value pair, do count per key, and write it back out. In reality, you would probably also want a windowing statement up there if you're reading from an unbounded source. It's also very powerful. So session windows are one example of the power we have, that this is something that in other systems requires pages and pages of code to do. And it's just a very simple built-in concept in Beam. You can session it and you get these dynamic per key windows based off activity. However, the big but is I have picked the examples in the previous two slides where things are simple. But, and a counterexample, when was the last time you tried to write a join using the Apache Beam SDK? If you haven't, here's an example of what it will look like in at least the Java SDK. So there's this transform called KulturBrauerei that lets you merge two P collections. It's fairly cumbersome to use. You have to tag all these P collections with another type tag called a tuple tag, which is a way of taking a string and adding a type to it. You KulturBrauerei it together, then you need to extract things, then you need to iterate over the things. This is the code to do a fairly simple join. This type of join that would be 1 or 2 lines of SQL. So when we get here, we're clearly not making things simple. And I think as a result, when people talk or learn Beam, joins, KulturBrauerei is often pitched as an advanced feature of Beam. However, joins shouldn't be advanced. In SQL, joins are part of your bread and butter. They get pitched as advanced, I think, just because it's advanced to know how to do it. It's just learning all this, how to write all this code is a bit more advanced. And that's what we would like to fix. Apparently there's an empty slide. So another example, let's say you're calculating parallel aggregations. I'm reading in one P collection, and I will have I want to calculate a sum, I want to calculate a count, maybe a histogram. How do I do that in Beam? Well, again, there's a way to do it. There's a transform called compose combine that you can pass it multiple combiners and combine it. And again, it's not great. It's a very similar thing. You have to create a bunch of combined funds, create a bunch of tuple tags to identify each combined fund, compose them, then you have to, get a co-combined result back, extract all the results. It's a little bit simpler than the join, but not much. Again, if you're thinking SQL, you would just do select aggregation, select count of column, comma, sum of column, comma, something of column, and it's 1 or 2 lines of SQL. This is not a great state of affairs. I think often what's happened is we started off with this idea of making things simple and hard things possible. But what happens practically is you make hard things possible, and then people talk and say, okay, yeah, we can make this simpler, and we'll do it as a phase 2. And then phase 2 never happens because everybody starts working on something else, and nobody ever gets around to making those things simpler. And over the years, these things just add up, and you end up with more and more things that nobody has gotten around to simplifying. I'm not sure why all these blank slides keep ending up in here. Oh, so here's another example. Writing to a database. So as an example, using BigQuery, which is one cloud-hosted database, but this would apply to most. Usually writing to a database, you're writing to something with a schema. So with BigQuery, every time you write, you must first tell it what's the schema of the database you're writing to, and then you have to take whatever your input element type is on your P collection and convert it to a table row object, which is the object that BigQuery wants. So you want a page of code here just to take a P collection and write it out to your database. Like another example of things not being simple to use. All right, so how can we go about fixing this in the API? Oh, so going back to easy things easy and hard things possible. So the idea we've been pursuing for the past year or more is schemas. So what is a schema is essentially we take a P collection and augment it with a descriptive type system. So where each P, you can identify the type system of each P collection as a set of fields and values, where a field has a name and a type, and then you have a value for every field. Sources can set schemas, and Beam is able to infer schemas from many types. So in the Java API, if your P collection is a Java Pojo or a Java Bean or an Avro object or soon a protocol buffer object, an auto value object, Beam can automatically reflectively examine your objects and infer a schema. So here's an example of a schema. So in this example, we have several streams of data. One is purchases. A purchase has a user ID, a product ID, a transaction ID. These are all strings, and a location. And a location is a nested schema, so schemas can be nested. The case then is a latitude, longitude, and a region. We have a stream of transactions. A transaction is essentially a credit card transaction, and a stream of product reviews. So this is a set of schemas for a hypothetical retail company, where every time somebody makes a purchase, we get a purchase event with this schema. Every time somebody makes a credit card purchase, we get a transaction, or maybe multiple transactions if they're splitting the payment across multiple credit cards. And then they can come to our website and leave a product review, and we'll get a product review event. And as you can see, rather than the standard Beam story where types on a P collection are just opaque things with maybe a coder that can encode it and decode it, the types are now introspectable. They're divided into different fields. You can examine the fields, you can select the fields, and so on. This is not a new idea. Database folks have known that this makes it easier to analyze things since at least the late 1970s, if not earlier. Other systems, data frames, and Panda data frames, Spark, data sets, and so on have also gone down this path. So there's nothing new in the idea that most data can be broken down this way for ease of analysis. So how does it make things better? Well, let's look at the APIs we now have. These APIs are already in Apache Beam to solve the same problem with schemas. I want to do a join. Well, this is the code to do a join if this input P collection has a schema. I can just say, in this case, user purchase is say a Java Pojo, for instance, or maybe an Avro specific record. I can just say join inner join on transactions, where transactions is another P collection, and I just pass in the name of the field I want to join on. In this example, this is what you would call a natural join in SQL, where we're joining on the same field name. Then I just want to select two fields out of the join, select, and then pass in the fields I want to extract. The join produces an LHS and a RHS subschemas. So select LHS user ID and total purchases. Now group by user ID, aggregate field, and just pass in a combiner and say, I actually left out, this should be aggregate field purchase, so I actually left out that out. But you can just say aggregate any field in the schema, aggregate it with this combiner, and create a new field in an output schema of this name. And I can put multiple of these. I can do aggregate field, that aggregate field, that aggregate field. And then the output of this is going to be a row object. Just say convert to user purchase. And as long as this convert transform will verify that the schema matches, and if it does, it'll convert it to that POJO. Multiple aggregations. What was so hard to do with this compose combine? Well, this group transform we just saw, you can just nest these aggregate fields. So take transactions. Let's say for every bank, I want a few aggregations. I just say, OK, group by bank, and say aggregate field, aggregate the purchase amount, sum it together, and call it total purchase. Aggregate purchase amount again. Take a largest funds, call it top purchases, and do it again with approximate quantiles. This will just spit out a new P collection with a schema with three fields. One will be called total purchase, and it will be of type long. It will contain the sum. One will be called top purchases, and it will be of type array of long, and will contain it will contain the top 10 numbers, and one will be a distribution. And now I've simply and easily just done multiple aggregations on a P collection and just spit out a new schema. If anybody has used a data frames API before, this actually looks very similar to what you would do in data frames API. Just could nest these aggregations, and the output schema of this transform is based off of what I'm doing here. This is also already in the Beam API. Writing to a database. Well, we're working on integrating the schemas with all of our sources and sinks. So many sources, such as Avro, will already give you a schema when you read. In this case, the BigQuery API, all you have to do is say use Beam schema, and it will examine the Beam schema, translate it to the matching BigQuery schema, and eliminate all that boilerplate you saw before. But this is all about making the Beam API and these examples, the Java API, easier to use. What about people who don't want to write any code? There are plenty of analysts out there who feel somewhat uncomfortable even spinning up a JVM. Well, for that, we have been investing heavily into Beam SQL. And I believe there'll be more talks today and tomorrow giving more details about Beam SQL. But SQL is now something that you can express Beam pipelines in, or portions of Beam pipelines. So you can write code like this. Ignore the misspelled Kafka IO. It's not Kafka IO. But you can read a P collection and just apply SQL transform, and inside there just say select from P collection, which is the default name for the input table to this transform. So one of the tricks for implementing SQL with Beam is extending our timestamp and windowing model to SQL. And as you remember, some of you may have seen this slide before, events in Beam have timestamps. The timestamps may not line up exactly with the processing time of the event. So we have added support for 3 windowing types in SQL. And the syntax here is actually, there's a proposal to change the syntax for how it is in SQL. There's a current syntax which matches up close to what Flink SQL did. There's a proposal for a better syntax based off of table-valued functions, which may be talked about later. But tumbling windows is the equivalent of fixed windows in Beam. And you do this by adding a group by tumble to your SQL statement. Hopping windows is the equivalent of sliding windows in Beam. And by the way, we chose tumble and hop just because in the SQL community, tumble and hop were the more standard ways of describing fixed and sliding windows. And we've added support for session windows as well to SQL. And you do that by saying a group by session. So here's an example of a full Beam pipeline you could write in SQL. So in this case, we're selecting the product ID, the product description, and an aggregation, the number of transactions, so which is the number of purchases from a pub subtopic. I'm joining it on a bounded table. So I have another table which for every product ID just has a mapping of that product ID to some extra information. And I'm grouping it by product description. And then I add group by tumble to say I want to window this by fixed windows of 10 seconds. And then in this syntax, there's two magic things you can put in the select statement to say select the boundaries of the window. In the new proposed SQL syntax, it'll be a little bit cleaner. You won't have to have two separate functions that are magically correlated like this. But this is a pipeline that would take a little bit of coding to do in Beam or Java, and you can now write almost the entire pipeline in SQL. So what's coming up next for SQL and schemas? Well, we're working on portable schemas. So right now, schemas have mostly been implemented for Java. We're working on adding it to the portability APIs that were talked about before, which will also allow us to have schema-based transforms that run cross-language. In particular, it will also allow SQL to run from Python. SQL is currently implemented in Java, requires the input to have a schema. So if Python can generate a P collection with a schema, then it can just run the SQL transform cross-language, and now you can use SQL from Python as well as Java. So that is something we're working on now. As I mentioned, there's work on making the SQL windowing syntax simpler and probably adding more support for more types of functions to SQL. And SQL with retractions is another thing that people are talking about, and that is a way to allow SQL to work better for things that are not purely windowed. And that's the end of my slides. Thank you very much for coming.